This is the solution video for the advanced puzzle Siamese triplet 3, published June 28th of 2024, which is the third in a series of 3, and in all 3 there were 3 circles joined at a common intersection point over there, and in this case there is a triangle from those 2 intersection points to another one on the largest circle, and there are drawn 2 line segments from this midpoint to that intersection and from this midpoint to that intersection, and the task is to find the length proportion red to green. And the first thing I'm gonna do is I'm gonna draw this line segment, and because it is exactly halfway both sides, then it's a very well known theorem that it must be parallel to the base. So this line segment is parallel to this base line, and actually it is half the length because it's halfway up. Now we're going to use the result of the previous puzzle, Siamese triplet 2, and we use it to show that this intersection of the 2 smaller circles, the point I, is actually on the segment connecting those 2 other intersections. So they are collinear, and therefore I is on that segment we just drew. Well, now what I'm going to do is I'm going to draw this triangle from there to there to there. What can we tell? Well, from here in this circle, we see this cyclic quadrilateral, but this line is parallel to this line. So from symmetry, we know that it's actually an isosceles trapezium. Yeah, so this chord is actually the same. If I can say it here, these chords are actually the same. That's from reflection symmetry of this here in this diameter. But that implies that the angle over here, let's call it alpha, that angle is also over here. And for later use, using the parallel line, we know it's also over there. Yeah, we remember these are parallel lines. Now, exactly the same we can do on the left. We have here again an isosceles, excuse me, it must be isosceles trapezium, and therefore this angle beta, the angle beta is also over here, and because again the parallel lines is also over here. So what we have just arrived at is that this brown triangle is actually similar to the original triangle, and also similar to this smaller triangle. And moreover, it's not only similar to this, but it's also congruent. Yeah, because well, I have not shown that, but this is the same length. So we have there. So if you look, they are similar, and this side is equal to that side, that is to that. But this means that this line has the same length as this line. But remember, they are parallel. So what we have just found is that this quadrilateral is actually a parallelogram, and therefore the line segments red and green, they are of same length and they are parallel. That's a bonus. But the length proportion red to green is 1 to 1.